Ever wondered how scientists know exactly what elements are in a star millions of light years away, or how they check for tiny amounts of lead in your drinking water? It sounds like magic, but it's pure science, and one of the coolest techniques they use is called Flame Atomic Spectroscopy. So, what on earth is Flame Atomic Spectroscopy, or FAS for short? Let's break down the name. Flame. Yep, we're literally using a flame. Atomic, because we're looking at individual atoms. And spectroscopy, which is just a fancy word for studying how light and matter interact. So, FAS is a method to figure out what elements are in a sample, and how much, by basically setting it on fire and looking at the light it interacts with. Imagine you have a sample, let's say a drop of water you want to test. First, this liquid sample is turned into a fine mist, like a perfume spray. This mist is then mixed with fuel and an oxidant, and fed right into a flame. This flame is super hot, we're talking thousands of degrees Celsius. This intense heat does something amazing. It evaporates the water and breaks down any compounds, leaving behind free, individual atoms floating around in the flame. Now here comes the clever part. Each chemical element has a unique light signature. Think of it like a fingerprint. To read this fingerprint, we shine a special light through the flame. This light isn't just any old light bulb. It's a special lamp called a hollow cathode lamp that emits light at the exact wavelength that our target element loves to absorb. For example, if we're looking for sodium, we use a sodium lamp. This lamp shines light that is specifically tuned for sodium atoms. As this light passes through the flame, the sodium atoms floating in there get excited and absorb some of that light. They're basically gobbling up their favorite color. On the other side of the flame, a detector measures how much light made it through. If there's a lot of sodium in our sample, many sodium atoms will be in the flame, and they'll absorb a lot of light. So the detector will see a big drop in the light's intensity. If there's only a little bit of sodium, fewer atoms will be in the flame, they'll absorb less light, and the detector will see only a small drop. By measuring exactly how much light is absorbed, we can calculate the precise concentration of that element in our original sample. It's incredibly sensitive, able to detect elements down to parts per million or even parts per billion. That's like finding one specific drop of ink in an entire swimming pool. And we can do this for almost any metallic element, from calcium and magnesium to heavy metals like lead and mercury. We just need to swap out the lamp for the specific element we want to find. It's like having a whole set of keys, where each key only unlocks the secret of one element. So, from checking the nutrients in our food and soil, to environmental monitoring, and even in forensic science, Flame Atomic Spectroscopy is a powerful and reliable tool that helps us understand the chemical makeup of the world around us. It's a bit like giving scientists atomic-level vision. If you enjoyed this and want to keep exploring the amazing world of science with us, make sure to hit that like button and subscribe to New Einsteins. Got a question or an idea for our next video? Drop it in the comments below. Thanks for watching, and stay curious.